Welcome back to another lesson in physics. Today's lesson is on static electricity. Today's lesson is going to be a hair-raising experience. Everybody has experience with static electricity. I'm going to shock you.
Your friends and kill him.
Maybe you have experience with shocking your friends. The static shock is even strong enough to light up a light.
The static electricity was strong enough.
By now, hopefully you're excited to learn more about static electricity. Well, in order to understand static electricity, it takes physics. Our view of the atom has evolved throughout history. Beginning in the 1600s, experiments were performed to test the theory of the atom. We now know that there are three basic particles that make up the atom: the proton, the neutron, and electron. What we know is that the protons have positive charge and can be found in the nucleus. They are tightly packed and held tightly in place by the strong nuclear force of the neutral neutrons. A neutron walks into a non-alcoholic bar, orders a drink, asks the bartender, "How much do I owe you?" Bartender says, "For you, no charge." So the neutrons are also in the nucleus, and they provide the glue that holds the protons together. The neutrons and the protons are stay put in the nucleus. You're not going to move the protons or the neutrons unless the atom were to undergo a nuclear reaction. Electrons, on the other hand, are negatively charged and are found vastly far away from the region of the nucleus in what we call shells. The electrons orbit the nucleus in shells and in discrete energy levels. Electrons are very tiny and very weakly bound in comparison to protons and neutrons. Electrons will move from atom to atom. The fact that the electrons move from atom to atom is the essence of electricity. In static electricity, we focus on the movement of the electrons. And we understand that the protons stay put in the nucleus. So what this means is that an atom can either gain electrons or lose electrons. If an atom gains electrons, it has an excess of electrons. This means the atom becomes negatively charged. If an atom loses electrons, it will then possess less electrons than protons, and so it becomes positively charged. Neutrons play no importance in identifying the charge of an atom because neutrons have no charge. Atoms which have no excess of positive or negative charge are said to be neutral. A neutral atom is one in which the atom contains the same number of protons as electrons. So what I have here is a model of a neutral carbon atom. I know it's carbon because it has 6 protons, but 6 electrons and 6 protons. 6 electrons and 6 protons will make it a neutral atom. What if the atom were to gain some electrons? So I'm going to add some electrons here. I'm going to add up to 8 electrons in the outer shell, because if an atom has 8 electrons, 8 valence electrons, it's full. 8 electrons makes the outer shell full. But if a carbon atom were to gain these extra electrons, So now on this model of an atom, I have, with this carbon atom, I've added electrons. So this atom is said to have gained electrons. And so let's count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 electrons It's a carbon atom, so there's 6 protons. And so this atom is said to have a negative net charge. And its net charge is -4. Now let's look at an atom if we were to lose electrons. So just let me take all these electrons in the outer shell off. And so with this model, it's showing that we've lost electrons. We're down to 2 electrons and still 6 protons. And so this model of the atom would therefore have a net positive charge, and the net positive charge is 4. It is common for the electrons in an object to move from the atoms of one object to the atoms of another object. When this happens, an object can become electrically charged. Objects which have an excess of electrons are said to be negatively charged. Objects which have a loss of electrons are said to be positively charged. Objects which have an equal number of protons as electrons are neutral objects. Charge on an object is measured with the SI fundamental unit of coulombs. And 1 coulomb is enough charge to electrocute a human and possibly cause death. Because it's such a large quantity, we often use microcoulombs or nanocoulombs. 1 coulomb is equal to 6.25 times 10 to the 18 electrons. 1 electron, remember it has negative charge, is equal to negative 1.6 times 10 to the negative 19 coulombs. And 1 proton, positive charge, is equal to positive 1.6 times 10 to the negative 19. I hope you enjoyed this short lesson on some basics of static electricity. Stay tuned for more to come. Have a great day.